Hello everyone. Welcome back to my second session on assignment problems. Today we are going to solve an assignment problem for minimization, and here's one example here. Simply you can see we have to solve the following assignment problem for minimization and also find the total cost. The values given here are considered as the cost. We have 5 rows and 5 columns. It means it's a balanced problem. Okay, the value of n will be 5 here, which will be used to check whether I have arrived at the optimum solution or not. To begin with, as you know, the first step number 1 is row reduction or row subtraction. So let us do the row subtraction. I'll write down the matrix again. Or let us directly write it, the subtraction part, and E. Okay. The first step is to find the minimum number from the first row. So which is the minimum number here? 8 is the minimum number. So we are going to subtract the smallest element in each row from all its other elements. Okay. So 8 minus 8 will give me 0. Again 8 minus 8, 0, 0. 11 minus 8 is going to give me 3. And finally 12 minus 8 is going to give me 4. In the second row, the minimum value or the smallest value is 3. Okay, let us do the subtraction. 4 minus 3 gives me 1. This gives me 2, 3, 0 and 1. The next one, 8 is the minimum here. So we have 4, then we have 3, 2, 1 and 0. The fourth one, minimum is 15. So 18 minus 15 gives me 3, this 6, this gives me 3 again, this 2 and 0. And the last one, the smallest number is 8. So 10 minus 8 gives me 2, this gives me 3, 2, 0 and 4. So this is my row reduction. The second step is to do column subtraction, where we find the minimum number in the column and then do the subtraction. But if you look at the matrix after row reduction, you will find that in each column we have a single 0 here. So there won't be any change in this column once we do the column subtraction. Here we have a 0, 0 here, again a 0 here. Here we have a 0, again a 0. So step 1 and step 2 will hardly make any differences. The matrix will remain the same. Okay, but still I'll write down the step number 2 for convenience. So step 2, column subtraction, and after the column subtraction I'll get the same matrix. So I'll quickly write down the matrix. We have 1, 2, 3, 4, 5. We have here 3 zeros, 3 and 4, 1, 2, 3 and 1 and a 0, followed by 4, 3, 2, 1 and 0. Sorry, this one is 0 and this is 1. So let me make a change here. This is 1. Okay, the values is A, B, C, D and E. Fine. So we have now the next one as 3, 6, 3, 2 and a 0. Okay, and the last one 2, 3, 2, 0 and 4. You can just check it again. So 3 zeros, 3, 4, 3 zeros, 3, 4 and 0, 1. Fine. So this is my second step where we have done the column subtraction, and because each column had a 0 in it, there's hardly any change. The next step, step number 3, is to draw horizontal and vertical lines such that you cover maximum zeros in a single line. So the number of lines which we are drawing should be minimum, and it should cover all the zeros. So if you look at the first row, we have 3 zeros here, okay, and we have 2 zeros here and 2 here, okay. So to cover all the zeros, will require a line here, 1, another line here and another line here. So I'll again put it back here. E 0, 0, 0, 3 and 4, 1, 2, 3, 0, 1, 4, 3, 2, 1, 0, 3, 6, 3, 2, 0, 2, 3, 2, 0 and 4. This is my matrix. I have rewritten it for the third step. And as I told you, you have to cover the zeros in minimum number of lines. Okay, so let us see. There are 3 zeros here, so I'll draw a single line here. So I have covered 3 zeros in a single line. Next, I have a single 0 here, 1 here, but if you look at the column, I have 2 zeros, so I'll draw a line here and 1 here. Now using 3 lines, I am able to cover all the zeros in this example. But as you know, the optimum solution is arrived only if the number of lines drawn to cover the zeros is equal to n. And what is n? N is nothing but the number of rows and columns. Okay, and n here is 5, so 3 is not equal to 5. So we'll go further and do the next step to improvise the matrix. Now pay attention to this step. In this step, what we do is we find the smallest value from the numbers which are not covered. So these are the numbers which are not covered, and the smallest number is 1. Okay, so this is my smallest number 1, which is not covered. This number I'll be using for my further calculation. Now what are the calculations? What I am supposed to do is I am going to subtract all the numbers, okay, like number 2, 3, 4, 3, 2, all these, okay. Subtract 1 from all these numbers. So 1 minus 1 from itself will be 0 here, then 1, 2, 3, 2, 1, 2, 5, 2, 1, 2 and 1. Whereas the numbers which are covered by single line, like these 3 zeros are covered by a single line, these numbers remain unchanged. Similarly, these numbers which are covered by a single line remains unchanged. But the number like 3 and 4 which are covered by 2 lines, okay, to this I am going to add the smallest value which we found from here. So I'll be adding 1 to 3, which will give me 4, and 4 plus 1, which will give me 5. I hope you have understood this. Let us do it here and rewrite the new matrix. So 1, 2, 3, 4, 5, A, B, C, D and E. Okay, the first three zeros are covered by single line, so I will just write them here. 3 is covered by two lines, so I have to add the smallest number. The smallest number was 1, so 3 plus 1 gives me 4. Again, 4 is covered by two lines, so I am going to add it up. So 4 plus 1 gives me 5 here. The other numbers which were not covered by any line, we are going to perform the subtraction. So 0, 1, 2, this remain unchanged. This is 3, 2, 1, unchanged. Then we have 2, 5, 2, unchanged numbers. Subtraction 1, 2, 1, and these are unchanged. Okay, so this is my new matrix. Again, we are going to follow the step number 3. And what is step number 3? We are going to cover the zeros with horizontal or vertical lines, and we have to use minimum number of lines to cover it. Okay, so I'll do this step here itself for your understanding. I won't rewrite this matrix again. So let us see how many zeros are there in the first row. We have 3 zeros. That means I can draw a line and cover it. All the 3 zeros can be covered here. Fine. We have 2 zeros here. We have 1 here, 1 here, 1 here. So I can easily cover 2 zeros, but let me check whether I have 3 zeros anywhere else. No. So I can draw a line here and cover this 2 zeros. Then there are 2 zeros in this one. So I'll cover this one here. And finally, I also have a single zero here. So either I draw a horizontal or a vertical line to cover this zero. I'll just draw this line here. Okay. Now count the number of lines. How many lines are required to cover all the zeros in this example? We have only 4 lines. Okay. The value of n is 5. So we have not yet come to the optimum solution. So let us repeat step number 4 again. Find the minimum number from the uncovered numbers here, which is 1. Okay. And this 1 has to be subtracted from all the numbers which are not covered. There won't be any change in the numbers which are covered by single line, and we are going to do addition for the numbers which are covered by 2 lines. Okay. So I'll do the calculation and rewrite this whole matrix again. So let us do this. Three, 4 and 5. A, B, C, D and E. Okay. So let us see the improvement. The first 3 zeros will be as it is. So let me write the first 3 zeros because it's covered by a single line. Okay. 4 and 5 covered by 2 lines. So I'll perform addition here. So 4 will be now 5. Okay. And 5 will become now 6. Clear? Again single line here and double lines here, so no change here. So 0, 1, 2, 0, 1, 2, and the other 2 numbers 0 and 1 is covered by 2 lines. So I'll perform the addition. So I'll get 1 and I'll get 2 here. The other numbers you can see we have 3, 2, 1. So I'll perform the subtraction. So this will become 2, 1, 0, 2, 1, 0, and 1 and 0 remains unchanged. 1 and 0. Next one is 2, 5 and 2, 2 and 0, these two numbers unchanged and do the subtraction here. So we have 1, 4, 1, and 2 and 0 remains unchanged. The last row we have 1, 2 and 1. So this will be 0, 1, 0, 0, 1, 0, and the other two numbers which is covered by single line will remain unchanged. So 0 and 4. 0 and 4. This was my step number 5, in fact 6, because I did the step number 5 in the previous step itself. So let us put this as 6. Okay. Now repeat step number 3 to cover all the zeros. We have 3 zeros here, so one line comes here. Okay, we also had 3 zeros here, okay, and 3 zeros. So now there are only 2 here, but we have 3 here, so I'll cover this line here. We have single 0, 2 zeros and 2 zeros. So either I can draw this one or this one. Okay, I will go for this one, and there are single zeros left and they cannot be covered using one line, so I'll require 2 lines here. So let us draw the lines. Okay, here we go. Now let us see the number of lines, count the number of lines required to cover all the zeros, which is 1, 2, 3, 4 and 5. And you know the value of n is equal to 5, which is nothing but the number of lines to cover zeros. Okay, so we have come to the optimum solution here. So the next step would be to do the assignment, step number 7 in this example, and let us do the assignment. For that I need to rewrite this matrix again so that we can perform the assignment properly. A, B, C, D and E. So we had here 0, 0, 2, 1, 0, 0, 1, 1, 4 and 1, 0, 2, 0, 1, 0, 5, 1, 1, 2, 0, 6, 2, 0, 0 and 4. Search for a single 0 in the row or a column so that we can perform the assignment there first. So you can see this row number 4, we have a single 0. So I'll perform the assignment by drawing a square here. Okay, and we have to cancel all the other zeros which are there in that particular column. So in this column we have a 0 here, so I need to put a cross. Okay, next one. As soon as I put a cross, you can see in this row I have a single 0 left. So my next assignment can happen here, and there are 2 zeros in this column which I need to cross. I've crossed it. Again we have a single 0 here in this row. Let us do the assignment here and cross the other zeros in that particular column. Okay, finally we have a single 0 here in second column. Do the assignment. There is no other zeros to be cancelled. Okay, and the remaining last one, this is the last assignment. Okay, here's my last assignment, and finally we have come to a solution. Now refer to the original values, okay, to find the cost. So cost, and I'll say min. Why min? Because it's a minimization problem and I have to find the minimum cost. Now A is assigned to 2. Let us see the original value for 2. So A was assigned to 2, so it is 8. Okay, so I'll write 8 plus. B was assigned to 1, so 4. C is assigned to 3, C is assigned to 3, so 10. D is assigned to 5. D is assigned to 5, 15. And the last one, E, is assigned to 4, which is 8. Let us do the calculation and find out the total value. So if you look at the total value, it will be, we have 10 and 15 here, 25 plus 16, that gives me 45. Okay, so this is my final answer. The minimum cost required in this example of assignment is 45. I hope you have understood this problem, and please go through it once again, step by step. Try to understand each step and do the problem. Thank you.